Factor theorem. So let's say I give you a polynomial with the px is equivalent to a x power of n plus b x power of n minus 1 continues up to q x power of 0. Okay, let's say I give you a value p alpha. Okay, I just substitute a value, a constant. Okay, alpha is going to be a alpha power of n plus b alpha power of n minus 1 plus up to q alpha power of 0. Okay, if p alpha, after you substitute all this alpha value inside here and then calculate, if you get alpha equivalent to 0, okay, which means alpha is a root. Okay, alpha is a root of this polynomial, and then x minus alpha is a factor of px. Okay, so first thing, if I give you any polynomial and then you substitute any constant inside the equation and you get the polynomial is equivalent to 0, means alpha or that particular value is known as a root of the function or polynomial. Okay, and then x minus alpha or x minus the particular constant is a factor of the polynomial. Okay, now let's look into an example. So here I give you an example, a polynomial px defined by x cubed minus 3ax plus 4a, which means here is a cubic polynomial where a is a constant. Given that x minus 2 is a factor of px, find the value of a. Since I said x minus 2 is a factor, okay, it's mentioned here, therefore p2 is equivalent to 0. Or how I can get this 2? So how normally I will get this is, I'm going to make it x minus 2 equal to 0, therefore x equal to 2. Okay, I take this value and substitute inside here, so p2 is equivalent to 0, which means it's going to be 2 cubed minus 3 2a plus 4a equivalent to 0. So it's going to be negative 6a plus 4a equal to negative 8. So negative 2a equal to negative 8. So a equal to 4. Therefore the polynomial of x is going to be x cubed minus 12x plus 16. So this will be the one of the example which we used a root of the factor theorem. Okay, let's continue. So here I mentioned that the previous equation and I give that x minus 2 is a factor. So how we can determine it's a factor? One is by substitute this value inside here, then we can say it's a factor. Okay, when we put 2, if you get the px equal to 0, then it is a factor. Okay, so another way we can say it is a factor is by using our long division. Okay, for example, x cubed minus 12x plus 6, so x minus 2. So by using long division, so it will be x square. So x cubed minus 2x square minus, so we get 0, 2 x square minus 12x plus 6. So going to be plus 2x. So 2x square minus 4x. 0, negative 8. Okay. Negative 12 plus, sorry, here is 10. 6. So negative 6. So negative 6x plus 6. 9. Okay. If we proceed with the long division, okay, if you proceed with the long division, when you divide the polynomial with the factor given, so you must not have a remainder. There is no any remainder. Then we call this as a factor of this polynomial. Okay, and then now we want to factorize the polynomial completely. Okay, we want to factorize. Okay, factorize the polynomial completely. Okay, so to factorize this polynomial, so what we can do, so since this polynomial, I can rewrite the product of here multiplied by here. So it's going to be px is equivalent to x minus 2 x square plus 2x minus 6. So I can rewrite this as x minus 2, and to factorize this 3, 2. So we cannot factorize this, so we can leave it that as it is. So x square plus 2x minus 6. So this will be the final answer for you for factorize completely. Okay. So first, if you want to identify whether the given value is a factor or not, what we're going to do is we're going to substitute this value inside and then find whether it is a root or not, or factor or not. To double confirm for you, if you want to find the multiple of which is a quadratic function, which you learned before, so you can use the long division. So a linear multiplied by a quadratic, you will get the cubic function. Okay, now let's look into another example. Okay, let's say I give you a polynomial of px. Okay, let's say I give you a polynomial of px, and then 4x cubed 8x squared, so equal to 4x cubed minus 8x squared minus x. Okay, so now I want to factorize the px. Okay, I want to factorize the px. So first, what I need to do is I need to find the root. So my first step, find the root. So how I can find? We're going to use try and error method. Okay, so what I'm going to do is we're going to substitute x value and then find. So let's say I'm going to give, let's say p, my x value equal to 1. What is it going to be? You can substitute any value. It's not necessarily 1. You can substitute with 2, 3, 4. So normally I'll start with the lowest number. Okay, I'll start with the lowest number. So I'll just key in 4 minus x plus 2. So when x equal to 1, I get negative 3. And then try and substitute negative 1, negative 9, and substitute x equal to 2, I get 0. Okay, You just calculate using a calculator, so you get 0, which means x equivalent to 2 is a root. Therefore, x minus 2 is a factor. After that, we are going to proceed the long division. So 4x cubed minus 8x squared minus x plus 2, so x minus 2. So to eliminate the first number, I am going to multiply this with 4x squared. So going to be 4x cubed minus 4 times 2 is 8, 8x squared minus 0, 0. So it's eliminate. So then I will get it negative x plus 2. So I put minus 1, so negative x plus 2 minus, so you get eliminate. Therefore, it's going to be the px going to be x minus 2, and over here is going to be 4x squared minus 1. I can rewrite this as x minus 2. I want to factorize this value, this polynomial. So it's going to be 2x minus 1, 2x plus 1. Okay? So I factorize completely, means I go for the lowest order of the x. So it's going to be x minus 2. When I factorize 4x squared minus 1, is going to be 2x minus 1, 2x plus 1. Okay? So this is the complete factorize of the cubic polynomial given here. Now I continue my first question here, and then I said solve px or polynomial of x equivalent to 0, which means this expression equivalent to 0. So what I can write instead of this, I can write my factorized version. So it's going to be x minus 2, 2x minus 1, 2x plus 1 equivalent to 0. So px equal to 0, so either this expression is equivalent to 0, or I can rewrite this, the factorized version. Okay, therefore it's going to be x minus 2 equal to 0, so x equivalent to 2, 2x minus 1 equal to 0, so x equal to 1 over 2, and then 2x plus 1 equal to 0, so x equal to negative 1 over 2. Therefore, to solve this, so your x value can be x equal to 2, or x equal to half, and x equal to negative half. So this will be the 3 solution for this particular value. Okay, when you have x power of 3, then you must have 3 solution. If you have x power of 4, you must have 4 solution. It may be a real number, or it can be a non-real number or complex number. Okay, but somehow if you have power of 3, your n value equal to the maximum n value is 3, then the number of solution must be equivalent to the power of the number of n. Okay, so this will be the factor theorem.